Hello everyone. Today we're going to talk about how to do feature engineering with dplyr, including how to create new columns based on the existing features in an original dataset. We're also going to cover how to combine different datasets into a new entity using different methods. So let's get started. We're going to continue using the wine ratings dataset from Kaggle. If you don't know what I'm talking about, please refer to previous videos in this series. Make sure that you already have the wine dataset as we produced it last time. If you're not sure, we're going to post this dataset on our GitHub page, so you could always download it from there. So I just opened up my RStudio and I have the data loaded on my machine. As you can see over here, it's the original data set after dropping 2 columns. So now it has 9 variables. We can do a quick view of what this data set looks like and make sure that you do have the exact same set as I do. So I believe we dropped the description column and everything else should remain the same. It still has the same number of rows as the original data set from Kaggle. So let's get started. First, I'm going to load dplyr. You should already have dplyr installed on your machine. So I already do, so I can just call the library. The first thing we're going to introduce is how to create a new column based on existing columns using a function called mutate. So I'll quickly demonstrate how that works. If I do the dataset's name and then use a pipe operator, I can do mutate. Here I'm going to create a new variable. Let's call it PP ratio because I want to find out the points to price ratio if I'm interested in the value in a wine. So in other words, if the points variable is high and price is low, then this PP ratio is going to be higher. So I just ran that and you can see, I'm going to scroll up here. We just created a new column called PP ratio. And these numbers are the division of points by price. One thing to bear in mind is that the mutate function is a non-mutating function, ironically, meaning we just did this line of code, but if we examine our original data set named wine, it's not changed even though we use a mutate function on it. So if we want to make sure, if we do want to append this new column to our original data set, we have to overwrite it by assigning this line of code to the original object name. So if I run this line of code now, it's going to override the original data set here. So after I hit enter, you should see that this data set called wine is going to have 10 instead of 9 variables. And let's do that now. So there we go. Another function that's similar to mutate is called transmute. And the only difference here is that when you do transmute instead of mutate, it's only going to produce the new variable that we're producing here. So we won't, instead of all these other columns like regions, winery names, countries, it's only going to contain this new variable called PP ratio. I'm going to run that here. Oh, it's pretty big. But as you can see, it's only going to, instead of a data frame that has that retains all the original columns from our original data frame, transmute only produces a new column. And if we want to, again, transmute is also a non-mutating function. So you can see over here, just to confirm that our y object is not changed, even though we just called this function transmute on it. So if you do want to produce a new object, let's create a new object called y1 and then run this function on it. Checking over here, this new variable, new object called y1 is has the same number of rows as our original data frame, but it only contains one variable, which is the pp ratio that we just produced. So now that you understand how transmute and mutate work, now let's go ahead and find out how many observations there are for each country using our old friend group by aggregation. So if I'm just curious and I want to find out which countries produce more or fewer wines in the set, I can do something like group by country and then summarize. Inside the summarize function, I can create a new column as well. I can call it whatever, but let's just call it total. And I'm gonna do the end function here, which is going to count the number of observations by each country, since that's a variable we're grouping by here. All right, so now we're running into a problem because there are 5 observations that have the country variable missing. Missing values are a common problem when we deal with any kind of real-world data set. But don't worry too much here because we're going to learn how to impute the missingness here. So if you want to find out what these 5 observations are that don't have a country specified, we can subset this data set by using this syntax. So here I'm saying that out of the wine data set, I want to subset all the rows that have the country variable missing, or all the rows that have the country variable set to nothing. So there's nothing in these quotes. And then I put nothing after the comma because I'm saying I want all the rows that satisfy this condition and all the columns. So I'm putting nothing after the comma. So after I run that, I can see that, not surprisingly, I'm getting 5 observations since the previous line of code told me that there are 5 missing observations that don't have country specified. So here we have these observations listed. And one reason I decided to subset these rows while retaining all the columns is that usually we can try to glean some information from the other columns. So even though for these observations, the country column is missing, they do have most of the other columns filled out. So we can always, it's always a good practice to try to impute the missing values based on the existing values. So in this case, we can see that, let's start with designation. So if I don't know what this word aestheticos means, remember to always be resourceful and just Google around or ask a friend who you might who might be knowledgeable in this area, and just be resourceful and try to look for information online and come up with an answer. So I just copy this word, and if I go to Google, I'm gonna search. All right, so I guess some results here. If I just click on some of them. Looks like this is a Greek wine, or it might be a region in Greece from what I can gather. So here it's confirming what I was suspecting. So looks like this designation implies that the country should be Greece. Going down the line, Shar might be a little more difficult, so we'll deal with that later. And if we want to find out where Pietra Feliz is referring to, again, just Google it. There we go. So it looks like this is a region or a place in Chile. So now we know that these last three observations probably have Chile as their country. So Sha may be a little more ambiguous, but if we go over here, we see that the specific wineries names listed. I don't even know how to pronounce that, but I'll just copy and paste into Google. And it's telling me that this is a winery in Turkey. So even though we started out with 5 missing values for country, we have just come up with a way to impute all of them. And the syntax for filling out these missing values in country, one way to do that is using the function called ifelse. This is not a dplyr function, it's just a base R function, but it's very useful as well for feature engineering. So I'll quickly show you how that works. I'm gonna go over here to copy and paste. So to explain what this line of code is saying, if else takes usually 3 arguments inside the parentheses. So the first one is a condition. So here we're saying that in this wine dataset, if the designation column is this word, if that condition is true, the second argument is saying that we want this country column, so in front of the equal sign here, to be Greece. And remember to put the word in quotes. So here's a condition. Here is what to do if that condition is true. And the third argument is what to do if the condition is not satisfied. So we're saying that in this dataset Y, if the country column contains if the designation column contains this word, we're going to fill the country column with Greece. But otherwise, just set it as the country column. So in other words, leave it unchanged. I'm gonna run that. You see that nothing's showing up, but after we run all 3 lines of code, we can check to see that everything worked. And I'm gonna do the same thing for Chile. I just press the up arrow on my keyboard to copy the last line of code I ran, just to save some time, and then I can just change the country and region names. So here I'm saying if an observation's designation is set to Pietra Feliz, I want the country name to be Chile, and otherwise the country name would be the country name, so don't change it. And the third one, because we arrived at the country name by winery instead of designation, I'm going to change designation to winery and just copy and paste the winery's name. Notice that we probably could have found out Greece and Chile based on the winery names as well, because these tend to be pretty specific, but designation worked for us, so I'm gonna leave that. Okay, so we just imputed all 5 missing values for country, and I want to confirm that everything worked, I'm gonna just keep pressing the up arrow button on my keyboard, and then do another group by summarize, and just to make sure that everything worked. So here we go. We see that there are no missing values anymore. One thing to note here is that even though we just imputed the missing values for country, and that was a mutating function, meaning our original data set called wine has been changed after we filled in the blanks for the country variable. The actual group by aggregation functions are not mutating. So we did something like this. Every time we just do a group by and summarize series, it's not going to impact the original data set we started out with. So here, if we want to create a new data frame that contains this new column called total, and we're going to arrange that from the highest to the lowest values. So if you remember from our previous videos, or if you already know this function, arrange, we're passing descending into a range in order to sort from the highest to lowest values. We're going to name this new data frame, just call it new wine. I forgot to actually pass in a variable within a range. So we're saying arranging by total from the highest to the lowest. Come over here to make sure that this new data frame has been created, and it has 48 observations and only 2 columns. If we take a look at what we just created, we can do view. So here you can see that group by aggregation produces new objects that only have whatever variable we grouped by and the new variable we create within summarize function. So even though the original wine data set had 10 variables, after the group by aggregation, we only have 2 now. So all the other variables that we didn't group by or summarize, like winery names, regions, prices, points, they just all went away. So that's something to bear in mind. And because of the volume of this data set, we're going to just create a subset of it. Let's call it subset 1. And we're just going to select the first 6 rows using the head function. And we're going to create a second subset. And this time we're going to choose the first 6 rows of the new wine data frame that we just created over here. And you can see that subset 1 has 6 observations of 10 variables because we chose the first 6 rows of the original wine data frame that has 10 variables, whereas subset 2 also has 6 variables, observations, but only 2 variables because, again, this new wine data frame only has 2 columns. So we're going to start talking about how to join data sets now, using 4 different methods to join these 2 subsets. The first one is called fold join. Remember that these join functions are also non-mutating. So we have to assign them to a new variable if we want an object to actually contain the product of the function. Otherwise, if we just use a function, it's gonna go away, and it's hard to call it later on. So the first function is called fold join. And I'm just gonna create a new variable called fold. I'm gonna pass in the data set names, subset 1 and subset 2. So here we see that we just create a new data frame. If we want to examine what it looks like, we'll just call it by its name called full. Here you can see that we have 9 observations, but some of these columns are missing. And that's because when you do a fold join, RStudio is going to include all the observations in both subset 1 and subset 2, even though these subsets have some distinct or non-overlapping values. So to demonstrate what I mean here, let's just take a look at what subset 1 and subset 2 actually contain. So you see that subset 1 has only has 3 unique values for country, whereas subset 2 has, not surprisingly, 6 because we grouped by country. So when we do a fold join, the result is going to include all these rows. And remember that the columns have to have the exact same name. So in subset 1, it's called country, and that's the exact same name in subset 2 as well. And even though subset 2 has 3 countries, Italy, Chile, and Argentina, that don't appear in subset 1, when we do a fold join, the resulting data frame, as we can see here, is going to include all these countries. And not only that, it's also going to include all the observations from subset 1. So you see that even though subset 1 and subset 2 both only have 6 observations, when we did a fold join, we get 9 observations. And that's because in addition to subset 1, that only has 3 unique countries, we're adding Italy, Chile, and Argentina on top of subset 1. And because subset 2 only has 2 columns and it doesn't have all these other features, designation, points, price, etc. It only has, but it does have this new column called total. For these 3 new rows that don't exist in subset 1, it's just going to show NA for all these columns that don't appear in subset 2 because we don't have values for Italy, Chile, or Argentina. So you see that all these columns are NAs except the very last one called total. The second type of join is called inner join. I'm going to create a new variable called inner and assign that to the inner join function. So exactly like the syntax for fold join. I'm just going to pass in the dataset names. So here you can see that whereas the fold object has 9 observations, the inner object only had 6. And let's just take a look at what they are. So here you see that we don't have any NA values. And notice that we also don't have Italy, Chile, or Argentina anymore like we did in fold. And that's because whereas fold join will combine everything in these 2 data sets regardless of missing values, inner join is only going to join the data sets by common values. So because US, Spain, and France are the only overlapping countries that appear in both subset 1 and subset 2, they are the only ones that will be retained after an inner join. So pretty much we just lost the values for Italy, Chile, and Argentina. The final 2 join functions are called left join and right join. And similarly, I can do something like this and create a new variable called left. And the syntax is exactly the same. You simply pass the data frame names into it. I'm also going to do right join. So left and right joins simply means left join will mean retain everything from subset 1, and right join will mean retain everything from subset 2. So come over here, we can see that left join has 6 observations, whereas right only has 9 observations, and that's because we created subset 1 is in a way a subset of subset 2, if that makes sense, because subset 2 has 6 countries, whereas subset 1 only has 3. So when we do a left join retaining only unique values from subset 1, we get fewer observations than we if we do a right join. That's because when we do a right join, we're retaining every unique value from subset 2, and our subset 2 has more unique country values than subset 1. That's how we end up getting more values from doing a right join than a left join. And the result of the right join should be the same as a full join. If we want to confirm that, we can just call it and see that we have all 6 countries with NA values for Italy, Chile, and Argentina. And if we want to look at the left variable, it looks the same as the inner join product. So it doesn't have the 3 values that only appear in subset 2. And remember that we decided to subset from the 2 different data frames, wine and new wine, or wine 1 rather. It's because we have over 150,000 observations, and doing joins would take too much time and computing power. So in order to illustrate how the join functions work, I selected these subsets just to make it more time efficient for the purposes of this tutorial. That's it for today's tutorial. Thank you for watching the dplyr series. If you've liked what you've seen so far, please check our other videos on YouTube, as well as follow our blog page. If you have any questions, be sure to ask in the comments below. Thanks for watching.